Welcome to Lighting Bot, and here is the beginning of our URP lighting episodes and tutorial, in which we're going to try and teach you everything that you need to know to get up and running with URP, and hopefully you learn a few things you did not know of. At the same time, we are hoping that you can solve some of the problems that we know are common among you Unity users. So I am using the asset of Adam, which is not available in Unity Asset Store. It's been deprecated. So unless you already own it or bought it, you will not have access to it. So if you want to follow along and practice, you can, however, go to Unity Asset Store and you can probably just download Space Robot Kyle, which I guess was the first version of Adam, and now that I look at it. So you can download that and you can follow along and practice with Adam's protege, or was it what is it called? I mean, Robert Kyle was first. Well, clearly I can see that. So the first thing we want to go through is the directional light. One more thing before we start is you probably don't have the lighting tab. I do mention it later on, but you click on Windows, Rendering and Lighting. That's where you get the lighting tab up and you can bake. Now for your case, you can have it, for example, on Shadow Mask, bake in Direct. For the timing, it doesn't matter really too much, but what I wanted to remind you is just to have the filtering on, at least on auto. If you don't do that, you're probably noticing this. You'll see all the noises, you can see that, and we need to put on the filtering to kind of get rid of the noise, which is often the case when you do your lighting anyway. It's about tweaking the filtering if you have too much noise. In my case, I have progressive GPU. You want to use either progressive CPU or GPU. This is not a lighting tutorial. You can go to my private channel for that. Okay, so I just wanted to remind you that this is the setting. You want to keep it on filtering and auto, and whatever light mapper and whatever lighting mode you want to try out during this session. Thank you, and let's go over to the directional light. Before we go into Unity, I am also trying to explain the concept of lighting just a little bit in this free course. So here we have an image of a directional light, and when I refer to directional as parallel lighting in the video in the future, I'm talking about the fact that every light has an equal distance, so to speak. And the reason the light has this distance is because the origin of the sun is so far away that by the time it reaches Earth, they are parallel, they are equal. That's the only reason. It's not really the only reason, but in this example we're gonna say that's the only reason, to make this free course as simple as possible. So if you look at the shadows, they all have the same directional shadows. They kind of even, and you can see it by the God ray as well. This is why the further away you put the spotlight as well, the closer the shadows become. You won't necessarily mimic the sunlight to that degree that easily, but at least you know why. Here's another example of the sunlight. One important characteristic with any lighting is the fact that you have a lot of bounce light. Now sunlight is a very strong light, so you'll end up with a light coming through and it will be bouncing around a lot, which is why we say the word indirect light and bounce light in this free course. Another characteristic with the sunlight is obviously the time of day. Depending on the time of day and the angle of the light, you should be changing the color of your light, especially the sunlight, because if you have long shadows, as you see here, it suggests sunset or sunrise. Therefore you want to add a bit of orange or yellow to your mood and lighting. I believe that's the last image I want to go through. The thing with the sunlight is, even though it's going through the glass or through to the wall, it is pretty bright. You can see in this room there is no other light source on, more or less, but look how bright the room is. That is very important to understand when you add your light, such as directional light. There's two factors here. There's the skylight and there's the directional light. In this episode, we're not necessarily going to skylight a lot, but we will cover it later in the videos in the future. Here I want you to observe the crispiness of the shadow, even though it's coming through the window, the glass. You can see it's pretty hard light, but the further away it goes, the further it travels, you can see it starts to blur out and it fades. So hopefully that's a good basic understanding before we go into the engine, because we really do need to understand how light works, even as simple as possible as this. So for example, this is a 3D version, right? So in this case you have light coming in and it is bouncing around. I do have to apologize, I don't remember who owns all these images, but it's for educational use, so I hope that's okay. You can see the lights coming in and you can see it's bouncing around, and this is just the directional light. And this is the kind of lighting I'm hoping you'll pick up and learn and focus on through these videos. You can see the shadows, they are not very clear and sharp like here. They are very diffuse, but there is still shadow coming around here, or occlusion as well for that matter. Okay, so let's dive into Unity. Okay, so let's add directional light. But before we add directional light, let's just clear up a few things. You probably don't see the lighting tab already, so just make sure you click Window, Rendering, and Lighting. This will give you the lighting tab. So again, you click Window, Rendering, Lighting, and you can drag it right there. We will be needing it later, but make sure you have Inspector up and running instead, because that is what we will be looking at. So let's add the directional light. I go into the plus sign, I click light, and I add a directional light. Now the thing with the directional light is that its position does not matter, but only which direction it's pointing matters. So you can see it's outside of the box. So normally, if it was a proper box, first of all, it will block the light. So if I aim up, you'll see that it's aiming light on top of this area on the cube. If I aim down, you'll see that you're getting light inside on the characters. If I aim left, you see that is coming from the left. If I aim right, you can see it's coming from the right. But there's no shadows. So if I go to the shadow type, I can then, for example, pick soft shadow, and you will see that you're getting the soft shadow. So maybe I want to make sure we can see some shadow and just add it something like this. Now when I add it like this, you'll notice a couple of things, I believe. Yes. So we will go through this again and again in the shadow chapter, but let's just go through it already now so you know something useful from the beginning. So with the directional light, you can change the color as such. I recommend following certain color palettes that make sense, and you can then create swatches. You can create swatches by adding it into this swatch here, and you can create a new library. You can call it sunset, and you can click create. And then, for example, let's say you are using this color in your project, you can always click this and it will quickly add it. And you can then switch between the color swatches depending on the project and style. That's a handy tip already, I would say. We're using real time for the sake of example. They are mixed and baked. We will go through it in the near future. Intensity is obviously the intensity of the light. Indirect multiply is for baked or mixed lighting, which is basically the amount of indirect light or bounce light that's jumping around, so you can fill in the darkness a little bit. This is the key thing a lot of you do not use. So when you're coming to me and you're saying it's too dark, it's probably because you didn't use indirect multiplier when you're doing baking. But we will talk about other solutions if you're not doing baking as well in the near future. Hard shadow instead of soft shadow has a more crisper and hard shadow, I guess, and softer, you can see, has a blur effect on it. It's not really blurring per se, I guess, but you get the point. A lot of the time when you guys say, okay, it's very dark shadows, I want to make them less dark, a lot of you will reduce the strength like so, and you will be like, yeah, that works. It's daylight, so you wouldn't have totally dark shadows, there would be skylight and so on. Well, I never recommend using this method. This is for me, this is an incorrect method, and I always keep it at 1 unless very rare scenarios. And most of you just need to learn more about indirect multiplier and post-processing and other techniques, so you don't actually need to use the strength. The resolution is the detail resolution for the shadow, so you can see if I do low, it becomes low. If I do very high, it becomes very high. If I go back to use quality settings, it stays the same. Why? Well, that's because it's using the quality settings, which is in project setting. Under quality, you see shadows, you can see its default is very high resolution. But if I do low, you'll see it's low. So at least you know where that is. So that is for directional light. You can understand it has a parallel shadows, which means they are all evenly distanced and they all go towards the same direction. Let us just quickly make sure we have a very simple basic understanding of how a point light or a bulb or an omni light works in the real life. It has one origin. It lies on every direction, 360 degrees. It follows the inverse square law. As you can see here, it falls down into darkness pretty quickly. That is the purpose of inverse square law. We will talk more about it in the future. Now, a lot of people, when they do digital lighting such as Unity or Unreal, they'll add a point light in areas like here because they know in real life that it tends to be a point light, right? It's an omni light, more or less. Now, in our context in Unity, because point light is very expensive, we obviously put the spotlight, and you will get the same effect using the spotlight actually. And you can see that the light is very intense. Near it, there's what we call an IES profile type of look here, and then there is the shadows from the actual light shade, and it kind of falls down into shadow pretty quickly. The contrast is fairly obvious here. Depending on the size of the light, you have to try and mimic that as well. So if it's a very small light source, don't make it super strong, super far away. The smaller the light source, the more likely it's gonna go quickly into the darkness. As you can see, this is a pretty bright light source, but because it's very small, you can see it goes quickly into the darkness. It doesn't travel too far. So you want to mimic these things inside your software. In this case, we are practicing Unity, so that's something to remember on. So let's go back into Unity and explore these simple terms a bit. The next light we're going to go through is point light. So for the point light, it's an omnidirectional light. So it's casting lights in all direction. It is also one of the more expensive lights. It's essentially 6 spotlights pointing at a different direction. Well, 4 spotlights. 6. 1, 2, 3, 4, 5. Yes, 6. So the next light we're gonna go through is the point light. Let's add the point light into the scene. Control Shift F just to move it quickly into the scene, and you will see that the position of the light matters drastically in this case. Let's turn on the shadow quickly, and you will see that the omnidirectional light casts shadows from its origin, which means it's casting not even light, but it's casting it in different direction. So you get some interesting spread and shadow like this. Like the other light, directional light, you can increase it, and you can also have something called range. So what the range does, it gives you more control on where you want the light to start and end. This comes under this law of inverse square law. Basically what inverse square law is, it says to the light that by the time it reaches the end of the radius, I want you to stop casting full intensity. So as the light is traveling, there's less intensity, it drops down. In this case, it also stops the light from going through this radius. Indirect multiplier still doesn't work because we're not baking the light in this example. And that is a quick introduction to the point light. The next light is the most versatile light, which is spotlight. There's not much to say when it comes to the spotlight. We kind of cover the basics, but the thing with spotlight often is you can see that they have a very specific, distinct look to them from the origin of the light. You can see there's a arc here, and then you can see the lights again spreading with its most intensity further down. Now the thing with spotlight, they cast a very specific shape and form depending on the angle of displacement of the light compared to the point light, right? So that is something you want to keep in mind, is where the spotlight pointing, and then you have the diffuse indirect light bouncing off that, and you can see that's happening here on the wall. It's pointing to the wall and then it's bouncing the light around instead of pointing directly. Because the thing with spotlight is they can often have very harsh lighting unless you have a lot of them and they're diffused, and they have a very specific shape that is very obvious like this. So very often people will use a point light or other things instead, but you don't have to. There are techniques we will learn as we go to deal with this. You can see a point light here as well, casting down and highlighting certain areas. This is much cheaper than using a point light. As I said previously, point light will cast light in all directions instead of a very specific direction that you have control over. So you could replicate this by actually having two spotlight with a larger cone. Okay, so let's go through the basic inside Unity now. The next slide we're gonna go through is the spotlight. So let's just quickly add that. Plus sign, light, and spotlight. Now the spotlight is the most versatile light. You have the range, which also follows the inverse square law, meaning the further away the distance is, the longer it takes before the light stops reaching the point, the origin, which is down here. So if I make it shorter, you can see the light ends quicker. And you have the spot angle, which is for the penumbra, which is basically the radius, and you can then have covered light a bit more in different areas. Let's just turn on the shadow very quickly. There's one thing I want to show specifically that should work in this example, and that is, you can see that it's not connecting, and that's because it's hovering a little bit in the air, but other than that this one is on the floor, right? But it's not connecting. This is often because of the bias in the shadow setting. So to deal with that, you can slide the bias down to about 0.01 or 2 normally. If you go on 0 when it's on soft shadows, you get an artifact. If you go on hard shadow, it's less visible. So that means if you need to have it on 0 for whatever reason, and there's no way you can have it any higher, you can then go from soft shadow to hard shadow, and you'll get rid of the strongest artifacts. Or if you want soft shadow, you at least want to make sure it's 0.01. You can see the character is no longer bleeding light through him. In this case, his name is Adam, right? You also have near plane. Near plane is basically where it cuts the shadow from the camera's distance. Normal bias is not something I can show here, but normally what it does basically is gaps like these, it will kind of crunch it together so you don't have them, and I don't think it's gonna do that here because of the type of model, but that's what it does normally. We can maybe, I'm just curious. No. Okay. Area light. How I would like to explain area light for the sake of simplicity is, I want you to think about area light as you would think about skylight or diffuse light in this case. Area light's purpose is to work as a softbox if you're into photography, right? It's a lot of lights being cast, and it's so many of it, and it's spreading around so evenly that it's very hard to spot the shadows. For example, in this image, it's very hard to see any harsh shadows on this statue, which is the concept of diffuse light. You can see it's very well lit. You can still see that there is some shadow, right? This is the brighted side on the right side, and then there is still the shadow side on the left, but it's so harsh in the background, which is like the sunlight, but this is not in the sunlight necessarily, so it's receiving what we call diffuse light. You can see the same here. It's out in the open. You can see there's some shadow coming on around there, but you can see it's evenly lit. You can see the reflection and a shape and form. Here you can see that you have the light on top of the ball, and it kind of slowly goes into gradient, and it's the same all over this statue as well. Again, I do apologize, I don't remember who has who actually owns these images, but again, these are for educational purposes, so I apologize. And here you can see that diffuse light is all about lighting up something without necessarily giving them very harsh shadows, right? And I will explain to you in Unity's specific case the fact that it doesn't necessarily cast shadow, but also that it has different challenges. So you would normally use it for windows or something very specific, for example studio lighting and so on. But again, there are other ways of doing the same thing differently, using emissive lighting, for example, which we'll also go through in the future. So let's jump into Unity. The next thing we want to go through is the area light. Now, I personally don't use the area light a lot because it comes with a lot of complication, and there's a very specific use purpose. The area light is baked only in the URP pipeline. Therefore, let's just do it quickly so you can get a basic understanding of it. The size of the area light defines the intensity, even though we have an intensity as well. Let's just bake generate the light quickly so you can see what I mean. You can see that it's casting light everywhere, but you can see it's not really casting any soft shadows or hard shadow. That's one of the disadvantages of trying to do area baked light. It works well for natural lighting or very diffused lighting. If I make this super small without doing any other changes, I'm gonna do generate light, and you can see that the intensity actually drops. So the size matters. So if you have a window and that is its size, obviously you want to increase the intensity instead to, for example, 10, and you'll see that it does the job. Now you can see there is a black area here. Normally that happens because the range of the backlight is a bit annoying actually. So let's turn it down to range 5, and I'll do a general lighting. And basically you can see this is the 5, so it stops casting the light, and everything else is indirect lighting now outside of this and behind here. So if I turn off the indirect lighting, which we haven't looked at, and I do general lighting, you can see it's more or less pitch black, and this is the range. And then if I go to say 12 in range, click general lighting, you see that it's starting to cover the whole area. In other words, you could have 3, and you could have 10 in direct lighting instead, and you could have 5 in range. Just a quick example, and I can bake the light, and what you'll see is you get the room pretty filled up, but you'll still see that this is the range of 5. So you want to use it in a very specific context, like for cars or very specific shot. Like it can work in this shot because there's one camera, we're not moving the camera, so you could use it in this case if you wanted to fill the background, make it flat or whatever. So hopefully that's useful. This is a very quick introduction to the type of lights and different scenarios that is useful to know. Now, there was one thing I purposely didn't show. Well, technically there are 2 things I didn't show you, but let's focus on one thing, and consider this an end of the lesson challenge. I will show you it, but I will show it on the next video. As you saw with the area light, what you can see now compared to the previous clip earlier in this video with the area light is that in this example it's affecting the characters. In the previous example it was not affecting the characters, it was only affecting the environment. So I want you to figure out why that is the case, right? So you want to figure that out. You might have seen the pop right now in this video. You can see it's happening over here. Okay, I'll pause the video and I'll show the difference so you actually can try and spot the difference without revealing what you need to do. Ready? I'm gonna bake the lighting. Watch this area. You see what happened? It didn't occlude, it didn't create the shadow it should have, right? So these are the things you will be learning in my videos. It's these subtle things so you know that something is off or something isn't working. Okay. So in the first example of the area light, it was pretty dark on the characters. In this example, they looked like they're lit, but they aren't actually as well lit as they could be. So why is that? Leave a comment when you figure it out, or actually better yet, go to Discord and message me, so those people don't know. So that would be interesting to see. Okay, so see you on the next video now, where I will be discussing other topics such as backlighting, emissive, and a few other things. And as we progress, there will be more and more content diving deeper into these differences that can be a bit daunting and complicated. So hopefully you'll stop sliding things randomly, but actually know what you're doing and why you're doing it. Thanks for watching and have a nice day.